Welcome. For those of you coming looking for review number 1 for the final exam review, we are going to get there, but I just wanted to take a moment to explain a couple of things that could be helpful as you're doing your reviews. So here's our review we're working on. For each section that we've got, I've got a section number next to it. Now, we're going to take a look at a problem in each section, but it doesn't cover every possible thing that you could come up with. So here's just a couple of suggestions if you're looking for some extra help outside of class. If you take a look over at my YouTube page here at Harty Math, and you found out, that first section was giving you trouble, it was section 1.7. All you've got to do is go to the little search engine, hit 1.7 and hit enter, and you'll be guided to where the video is for this. So there's really not a lot of place that you have to go looking very much. Now, we've taken a quick switch over to my website for a second. Again, if you're looking, you can go through the Harlem site, or you can go to huskiesmath.edublogs.org. And let's say that 1.7, the video didn't quite do it for you. You like to see some problems written out where you don't have to keep watching the video. So if you just come over here and wrote 1.7 notes and hit enter, you could go in, and you're like, well, it doesn't say 1.7 notes directly here somewhere. You're right, it doesn't. But if you start clicking on the links and just scroll down a bit, oh, there's 1.7. Oh, here's the notes with all the examples, because maybe I misplaced mine, okay? Those are a couple of options for you to consider when you're doing these, okay? Now back to our regularly scheduled programming here with the review. So solve the inequality and write your solution in interval notation, okay? Two things to remember here. I'm going to have two inequalities for each of these. That's one thing I want to remember. And the other thing I want to remember is I need to get my absolute value alone before I even start. So I'm going to start with one like that, and then we're going to have to, kind of play it by ear. So let's say we do number 3. My first job is to get this by itself. So I got to do the opposite of this, minus 9, to be able to accomplish that. So I plus my 9 to the other side. So that always has to be job 1. Number 1 and number 2 already did that. So once I get here, I got to split this into two inequalities. The first one I do, I just copy what I see. I just don't use the bars anymore. The second one that I create, I don't touch what's inside the bars, but I have to switch the arrow and change the sign of the solution. And that always works for these. So once I do that, and I'm going to go through and attempt to solve these. Now, after I minus my 6, when I go to divide at the end, dividing by a negative, dividing by negative 2. What happens to the inequality arrow when we divide by a negative? I end up having to flip it and have it go the other direction. So, my k, my 1, but now my arrow is going this way. My k, my 5, arrow switches that way. Okay. So those are my actual inequalities, but I'm not quite done, because it says write your answer in interval notation. So my plan always with this is to draw myself a little picture with the 2 points that I've been given, and to figure out what this would look like as a picture. So if k is less than 1, less than is left, because that's where my values get smaller. K is greater than 5. Again, if it's eating the k, that's what the greater than sign is. And I go this way. So when we do interval notation for that, we always work from left to right. So, well, left, it's going forever to the left, so that's negative infinity. So as I go from forever to the left and come, here's my first stopping point at 1 with a parenthesis, but I see there's some more going on over here. So I start back up at 5, and off to the right I go. And that would be my interval notation. So again, If it's less than, maybe it colors inside, in between. I don't know. But again, if you want more information, back to 1.7, you can do that. Okay, solve by completing the square, and that's 5.5 if some of you are kind of squinting trying to figure out what that number is. So again, let's look at one of these. Let's say we've got number 5. It's as good a place as any to start. My first job is to get my variable terms alone on one side. So this minus 6, well, this plus 6 has to get moved to the other side by minusing 6. Once I've done that, we go through our little step process that we did before. I'm going to take my b term, which is just the number in front of my variable term, not the squared one, but the one that's n or x, whatever it happens to be. I'm going to divide it by 2. And then I'm going to square it, use the parentheses. Whatever number I get out, I'm going to add to both sides of my equation. This is the square part of completing the square. Once I get here, I need to get it into its binomial form. And we talked before about I could do the diamond on this, but the faster way is just to take my b divided by 2 number, my negative 5, and put it in there. And then my last step, again, well, one of my last steps, I'm going to square root. We talked a little bit about this yesterday when we were talking in section 7.6. Those will cancel out. It's plus minus because it was a quadratic, which means there's 2 answers. And I've got to break my square root of 12 down. Square root of 4 is 2. That's the one that breaks down nice because it's a perfect square. Square root of 3. And just a reminder, if you have trouble with this, you're like, I don't know my perfect square. Remember, you have the green sheet. I've still got some extras yet, so let me know. We'll get you hooked up. And that's how I'm going to complete the square. But again, if you want to see more of this, if you want more examples that are worked out, 5.5 is the place to go. Okay? Factoring. Now, I could do 6 factoring problems here because there's so many different things that go on. But I'm going to pick out a couple that I think would be most helpful. And then again, that green sheet that I just had up is a great tool with this too on kind of helping you see how some of this is going to work. So, okay, let's say we're looking at 9. Always, 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 always look for something they have in common first, the golden rule. I can divide both of these by 5. They both have u's, but you're always going to take the one with the smallest exponent. And let's see what we got left here. I already got the 5. To get from 2 to 4, I need 2 of those. To get from 5 to 50, okay, that's 10. I already got the u's. If this were like u squared minus 9 or minus 4 or minus 25, something that's a perfect square, I could keep going. But sometimes it's just going to be that, and I'm done. So again, no big worries, no big concerns. Okay, I get into a problem like 11. Don't let the 4th freak you out. I'm going to treat this like it's 8x squared plus 18x plus 9. So, well, how would I do that? Well, I'm going to slide and divide. And once I did this, I'd be looking for 2 numbers that multiplied to 72 and added to 18. So again, if this isn't my greatest skill, I bust out my chart. And I'm like, okay, well, here's a 72, 8 and 9. Does 8 and 9 add up to 18? No. Okay, let's try again. 72, okay, here's a 72. 12 and 6. Does 12 and 6 add up to 18? It does. But I'm not done. Oh, no, no, no. This is called slide and divide. So that 8 that I slid down before, I'm going to put in here. Now, I know 6 doesn't go into 8 nice. 12 doesn't go in, 8 doesn't go into 12 nice either. But I have to reduce the fraction before I can keep going with this. So in this case, If you're not sure, take your fractions, math enter, enter. And I'm going to do the other one for you. Save us a little bit of time here. But once it's reduced, if that's all I can do, that denominator of my fraction just swings back to the front. And I get to my answer. And again, whenever we're doing these, if it's a shorty, check it out. Green sheet, 2 terms. Ooh, difference of squares. Are those squares? They are squares. Take advantage of the tools that you have. And if you need to hit square root of 25 in the calculator because you don't remember what the square root is, do it. Minus means one of each is in there. I'm good. But again, you're already noticing through the first 3 problems, we've done 3 completely different things. Take out a common factor, slide and divide, difference of squares. That's why you have the green sheet to help you. They're not all going to be the same. Sorry if that's what you're looking for, but that's not how this works. Okay, 16, you look at it, you're like, ooh, maybe it's squares. Oh, wait, that's a 3. Oh, those numbers are cubes. Okay. So remember when we were doing cubes, what do I cube to get 64? 4x. What do I cube to get 125? 5. What if I don't know what the cubed root is? Because even though we've said we need to know this, I haven't done it yet. Okay, here's your option. If you're ever looking to see if something's a perfect cube, you can take it to the 1/3 power and get the answer. Got to use the parentheses, okay? Because there's not another fancy button on these calculators to help you. So take anything to the 1/3, you get it. And then I keep my sign in the middle. So then my pattern goes, and again, it's on your green sheet. Square my first term, the 4 and the x. Change signs. Multiply them together. And then square my last term. The nice thing about these, they never break down more than once. But again, if you're having issues with these, the sections are there. Use the information provided to write the standard form equation of a circle. Okay? First job, I got to get all of my x's together with an extra blank. We'll talk about that in a minute. Got to get my y's together. You're like, Harty, there is no other y here. Okay, well, I'm going to use 0. And if you don't have a variable, you must move to the other side. So there we go. Once I do this, we're going to complete the square for both of these. So you take the 24, divide it by 2, square it. That goes in both sides. You're like, well, what do I do with 0? Because 0 divided by 2 is 0. 0 squared, right, it's just 0. Okay. So my last job, because I'm not solving here, I'm just getting into the standard form equation of the circle. X, there's my positive 12, just like when we completed the square. You're like, okay, what about y? It's all zeros. Okay, just write y squared. Or if you want to write y plus 0 squared, that's okay. And then negative 135 plus 44 is 9. That's it. That's the equation of a circle. And I'm set. Solve each equation. Just like the absolute value inequalities we were doing on the other side. I got to have 2. Leave the first one alone. Second one, don't change what's in the absolute value, but we're going to change the answer because we got to get 2 answers. Okay. And we still need to isolate the absolute value. It's got to be alone before we start. Here it was. There, I'm going to have to add 2 first. And if you get an answer that's kind of funky, I'm not going to write them up as decimals. If you want to, you can, but that's all I'm basically doing. Minusing my 9 and dividing by, and I'm set. Let's see what else we got here. Identify the domain and range of the following polynomials. Well, I got to know what it looks like before I can tell you what the domain and range is. Just clear that out. X squared minus 4x. Graph. My domain, my x values, this goes forever off to the left, forever off to the right. So negative infinity to infinity. Now, my range, that gets a little more interesting. This is my y values. Well, I see it goes up forever, so I got that part. But where does it start? What's this down here? How can I find that? I want to find that using a minimum. So in this case, my minimum, or if it was flipped the other side, a maximum, is going to be found by using second trace, and for ours in this case, number 3. And just like we did before, we're going to go down to where we think the minimum is, and once we get there, we're going to click a couple to the left, we're going to hit enter, we're going to do a couple to the right to get back where we started, and a couple more to play it safe. And it looks like my minimum says at 2, -4. But which value am I interested in? Well, it's the y values. So I'm interested in the y value, -4. And I'm good. Okay. And that's going to be the same thing that's going for 25 and 26. If there's a bottom or a top, it doesn't go forever. You've got to find that minimum or maximum using the second trace function and then looking for those. So that's going to wrap us up for review number 1. Review 2 coming soon.